Hello. Good morning. Okay, let's solve one problem on the class what duration we did in the last class. Okay, the first problem is a spring mass system with a spring stiffness 5000 Newton meter is subjected to harmonic force of magnitude 30 Newton. Okay, and the frequency is 20 Hertz. Okay, the mass is found to vibrate with the amplitude of zero point 0.2 meter. Okay, assuming that vibration starts from rest. Okay, rest means initial condition. Okay, so that is the assumption. Means vibration starts in the initial from the rest condition, it is starting. Okay, that point the displacement and velocity both are zero. Okay. Now you determine the mass of the system. Okay, the question is like that: there is a spring and mass system. Okay, there is no damper. The spring characteristics, that is stiffness, is 5000 Newton per meter. Okay, then the force which is exciting this system, it is 30 Newton at frequency of 20 Hertz. Okay, so with that frequency, with the magnitude of 30 Newton force, it is operating. Okay, so the displacement, the amplitude, okay, of the mass is zero point 0.2 meter. Okay, that is the peak, that is the maximum displacement that can be achieved by the mass. Okay, now we have to find out what is the mass of the system. Okay, see how we want to find out. Okay, let's begin. First, what is given? Stiffness of the spring. Okay, so that is 5000 Newton per meter. Okay, next, initial force F naught with a magnitude of 30 Newton. Okay, so next it is operating at a frequency of 20 Hertz. Okay, it's given. Then my amplitude of vibration is zero point 0.2 meter, that is also given. Then we have one assumption. Okay, what is that assumption? So x naught and x naught dot. X naught is initial displacement, x naught dot is initial velocity. So both are zero. Okay, now we have a spring mass system. Okay, what is the response of spring mass system? We have done a derivation. Okay, so that response is given by this one. Okay, this is the derivation what we did in the last class. Okay, so xt is the response, that is displacement of the system, which is given by x naught minus f naught divided by k minus m omega square cos omega nt plus x naught dot omega n sin omega nt plus f naught divided by k minus m omega square cos omega nt. Okay, cos omega t. Omega is exciting frequency. Okay, but omega n is the natural frequency, that is root k by m. Okay, so this term and this term, okay, both are c1 and c2, that comes in the harmonic solution. Okay, so this term is particular solution. Okay, I think you now understood what is this equation. Okay, this is equation the representing the response of spring mass system under harmonic excitation. Okay, here it is under harmonic excitation, the excitation frequency omega is 20 hertz. Okay, now we see, now we have to find out the mass of the system. Okay, how to find out mass of the system? Okay, now substitute the given assumption into this above equation. What is the given assumption? That is zero, displacement and velocity both are zero at the initial condition. Okay, now you substitute in this equation x naught, that is zero. Okay, this term will become zero, so this one remains same. Okay, next, x naught dot, that is 0. When the x naught dot is 0, this entire term will become 0. Okay, so this will be eliminated from this equation. Okay, here nothing is there, so it will remain as it is. Okay, now what is the equation? Rewritten equation is xt f naught k minus m omega square cos omega t minus cos omega nt. How it came? See here, x naught is 0. Okay, so this term remains same, this term remains same, so f naught k minus m omega square cos omega nt, so that is here. Multiply this, so this will remain this equation. Okay, next one is f naught k minus m omega square cos omega t. Okay, so that is this equation f naught k minus m omega square cos omega t. So we have taken out the common. Common is f naught divided by k minus m omega square. So it remains cos omega t minus cos omega nt. Okay. Now we have to simplify this. How to simplify this? There is a trigonometric equation. So what is it? Cos A minus cos B. Okay, what is that? So equation cos A minus cos B, which is equal to 2 minus sin A plus B by 2 sin A minus B by 2. Since 2 is minus 2 is there, so you can interchange the A and B. Okay, so that is also possible. Now you substitute A and B into this equation and rewrite this equation in this form. Okay, how to rewrite? Now we see. Okay, so xt is equal to, this remains same, since here it is 2 is there, that will come here, 2f naught. Okay, sin omega n is b plus omega, since it is negative it is there, so we swapped here, omega n plus omega divided by 2. Okay, next multiply, it is not plus. Okay, sin omega n minus omega divided by 2, okay, into t. So don't confuse with a and b here, since negative is there, so yeah, swap it. Okay, so 2f naught divided by k minus m omega square sin a plus b divided by 2 sin a minus b by 2. Okay, that's what the simplest form of this equation. Okay, now we want what we have here, amplitude of vibration, that is x. Okay, so in this equation, which is x? X is this term. Okay, why? Because this is the displacement with some function. Okay, so this equation will equal to x. Okay, why? Because the maximum value will be 1, maximum value will be x when it is 1. Okay, so now what you will take? So maximum, this equation equating to x. Okay, so that is the peak amplitude. So then the oscillation, amplitude of oscillation means vibration, is x is equal to f naught divided by k minus m omega square. Okay, x is equal to f naught k minus mm square. So this term is the x. So we have seen, right, xt is equal to x cos omega t or x sin omega t. Okay, same thing here. So the x is the peak amplitude, so you have taken here. Okay, see here, if you have confusion here, see here, this is particular solution we assumed, right? F is equal to x is equal to cos omega t, so x is the peak amplitude. So same thing here, peak amplitude of vibration is x. Okay, x is equal to f naught divided by k minus m omega square. Okay, now we have given, what is the given? Okay, 2f naught, see here it is, you have to put here 2. Okay, so here 2f naught plus 2f naught is there, so this is a peak amplitude, but we have 2f naught in the simplest form, so we have taken 2f naught k minus omega square, x is 0.2, that is given here. Okay, vibrating with amplitude of 0.2, that is the x. Okay, 0.2. Okay, now we know f naught. What is f naught? F naught is 30 Newton. Okay, substitute in this equation, f naught is 30 Newton, so I substituted here. Okay, next f is 20 hertz. Okay, so it is in hertz, so you have to convert it into omega. How to convert it into omega? Omega is equal to 2 pi f. Okay, write down, omega is equal to 2 pi f. Okay, 2 pi, okay, into f. So 20 into 2 pi, it will become 40 pi. Okay, 40 pi value is 125.66. Okay, now we have 2 into 30, that is f naught. K is 5000 Newton per meter. Okay, minus f is equal to 125 point, yeah, omega is equal to 125.66. Okay, laser pointer take. So it is 125.66 whole square, because whole square is there. Omega, here it is given in hertz, here it is in omega, so that's why I told you last. Okay, so don't confuse with f and omega. F will be always in hertz, omega will be always in radian per second. Okay, so omega is equal to 2 pi f. Okay, 2 pi into f is 20, so 20 into 2, 40 f. Okay, 40 pi, 40 pi value is 125.664. Okay, whole square. So x value is 0.2. Okay, now if you simplify, so the answer will be m is equal to 0.2976 kg. How to solve? Zero point 0.2 into 5000, it is equal to 1000, minus zero point 0.2 into 125.664 whole square into and 2, so you will get some value. So here it is 60. Okay, 1000 minus 60, you will get 940. 940 divided by this value. Okay, 125.664 whole square into zero point 0.2. Okay, 940 divided by 125.66 whole square into zero point 0.2. This is equal to m. So if you simplify that, you will get m is equal to 2.976 kg. Okay, this is the mass of the system. Okay, so we have one mass, one spring, and the excitation. Okay, so that's what it is. So simplest one. Okay, this can be asked on 5 marks. Okay, 5 to 6 marks. This question can be asked in your examination. Not this question, similar type of question. Okay, so the values may be changed, or we may ask assumptions. Some assumptions we may give. So we may ask to, we have given certain velocity or at after some time. Okay, so the time will be given, so you have to substitute that time, then you have to find out the value of the mass. Okay, or they may give mass and they may ask to find out stiffness. Okay, that can also be done. Okay, so this is a question is there. If you have any question, you just ping me in WhatsApp. Okay, yeah, bye.